Everyone to the Spark Research YouTube channel. This is Dr. Vishanda, Assistant Professor in the Department of ECESRMIST Katankulatu. In this series, we are going to talk about this course Analog and Digital Communication. Primarily, we are going to take the questions which has already been asked in GATE 2025. So if you remember, we have already discussed some questions in the previous session, and now we are going to take some more questions in this session. Here is detail about the SRMIST, which is ranked on 14th as per NRF 2025. So why are we talking about this particular subject? Because the weightage is much more for this particular course, right? Analog and digital communication course. So the weightage is almost maybe in the range of the 10 plus marks. So this is the important, right? So here is the syllabus. Primarily you can check the random process, then the analog communication, then information theory and digital communication. So these are the parts of your communication. In this session we are going to take questions which is related to your digital communication, right? Okay, so this GATE 2025 has been organized by your IIT Roorkee. So here is the question. So question is, as per the consider a continuous time finite energy signal ft whose Fourier transform vanishes outside the frequency interval minus wct omega c. So actually there is a f of t, the message signal, which is going to be sampled, right? So it has been given that ft have the bandwidth, that is frequency range only in this, that is minus omega c to omega c. So of course omega c is the bandwidth, right? So outside from the omega c means the it is vanishes, that is why the bandwidth is very clear. So omega c is the bandwidth. Now how will it sample? So given the signal ft is uniformly sampled to obtain yt. Yt is the sampled signal. So how will you sample? So using this one ft into pt. What is this pt? Pt is the terrain. So pulse train. How will you the sample your f of t? So this is your pulse train, which is the the impulse function only, that is del of t minus tau and n of tau s. Tau is tau ts is your sampling time period, right? So exactly this is the how many numbers of pulse train is here? So infinite only, because minus infinity to plus infinity. Del t is the direct impulse, that is ts is also greater than 0. These are the things, the sample signals yt. Then so this is ft, and here the sampling train, and so this is a sampled function, that is yt. And now after sampling your signal, yt is passed through the ideal low pass filter, right? What type of low pass filter? So this is your sync function h of t, that is omega c ts sine of x divided by x. So with cutoff frequency omega c, right? So the pulse the low pass filter also have the cutoff frequency of omega c, and passband gain is ts. These things are given. So now what is the requirement? So you have to find the output of the filter, right? So step one. So question is that actually you have to find out the output, the your filtered output waveform, that is y of omega. But thing is that how will you go? So your ft, that is message signal, is given having the band limited frequency is given omega c, and then go for sampling. And how will you do the sampling? So this is your sampling train, and after sampling how will you reconstruct? So just pass through this filter. This is your sync function filter, means rectangular function only, right? And then what will be the output? So check the output and find out the the ts, and you will get the value, alright, right? So as per answer key provided through this IIT Roorkee, your answer is, first answer is correct, that is a, that is f of t if your ts less than pi by omega c. So let's see how to solve. So here is the your original signal, that is message signals. So you can check here you have the bandwidth is omega c, and beyond that there is no masses. So in the time domain, this is actually the frequency domain. In order to solve these type of questions, you must know the frequency. How can you represent in the frequency domain your signal? Then only you can solve it properly, otherwise it will be difficult, right? So if you know how to show in the frequency domain, then it's very easy for you. However, for your information, I have also included the time domain signal. So this is your massive signal, right? Having the frequencies in the range of the 0 to omega c. Then sampling. So during the sampling, these are the terrain. So impulse train, right? So impulse train, with help of impulse train, if you will, you can sample it. If you are trying to sample, definitely your sampling rate must be follow the rules of the Nyquist rate, that is twice of omega c, right? Sampling frequency must be greater than twice of your your sampled frequency. So here you can check sampling signal, so that is your omega s must be greater than the twice of omega c, right? Omega is your sampling frequency, and twice, and omega c is your carrier frequency. Okay, then at the end, the last step is to pass your output, the sampled output, through the low pass filter. So in this question, since low pass filter is already given, that is your sinc function is already given. So again, your low pass filter have the cutoff frequency is omega c. So just pass it and get the output, right? So these are the three steps that we are going to follow. So let's see how to solve. So here now check first analysis of the sampling frequency. So this is your sampling frequency. So this is terrain, right? So del of t minus nts. It has already been given in the question. And then f of t is the our message signal, which is band limited signal, right? So here now we'll get the yt. How? So yt is your f of t into p of t. So you can get this using this Fourier the multiplication only. You can get this y of t, and once you will get the y of t, then our objective is to do the Fourier transform, so that we can get the y of omega, right? Why? Because then only we can find the frequency, sampling frequency, that is our target. So in order to find out the sampling frequency, we can find out the y of omega. In order to do so, you can find like 1 by twice by f of omega, that is Fourier transform of your f of t, and then p of omega, that is Fourier transform of your pulse train, that already has been given in the question, right? So this is the Fourier transform of a pulse train, and f of omega is Fourier transform of f of t, and simply multiply and get the y of omega. So this is the y of t, right? Y of t means your ft into pt, and then y of omega, just get the y of omega, and here you can check the f of sampling frequency, that is omega of s. Now filter. So last step is your filter. It has already been given in the question itself. The filter is what type of filter? Sinc function, right? Means what? Means h of omega. This is in time domain. In frequency domain, your filter, that is h of omega, is t of s will be only in between the minus omega c to plus omega c, otherwise 0. So this is actually the filter. You can also represent your filter like this. So this is a filter. So in order to recover the original signal information without aliasing, means error, the sampling frequency omega s must be at least twice the maximum signal frequency, that is omega c, as per the Nyquist criteria. So omega is your sampling frequency, we have already got it, and then your carrier frequency, that is twice of omega c. So now omega s, that is twice pi by ts, must be greater than twice of omega c. So here 2 cancel out, and ts must be less than equal to less than pi by omega c. So this is exactly, that is your how you can reconstruct your f of t, right? So y out, that is will be equal to h of omega. This is your filter, means the sinc function, and into your output that you got it from the y of your y of omega, and you can check it 1 by ts. You can put the values and you can get ts by ts, that is f of omega. So this is the confirmation that we can get the f of t, that is f of omega, at this particular ts, like so. That is why your option a is correct. Okay, let's take one more question. So question is, a source transmits symbol S that takes values uniformly at random from the set -2, 0, 2, right? So these are the three different values. So source will transmits, right? So the receiver obtains Y. Of course, source is transmitting these random signals, right? From this set, either your source will transmit -2, sometime it will transmit 0 or 2. But what about the receiver? Receiver will receive the information y is equal to s plus n. S is your -2, 0, 2, but n will be added. Why? Because of the noise. So where n is the 0 mean Gaussian random variable independent of s, right? So the receiver use the maximum likelihood decoder to estimate the transmitted symbol S. Okay. Suppose a probability of symbol estimated error Pe is expressed as Pe is equal to alpha Pn greater than 1, where P is depending on a probability that n exceeds the 1. What is the value of alpha? So first we are going to find out the PE, that is the the estimated error. So total error, once probability of error once we will find out, then only we can calculate the value of alpha, right? So that will be our target. As per answer key, your answer correct answer is your D, that is 4 by 3. So let's see. So here is your representation, how exactly we can find out. So what are the values of S? S is your the set of S is your -2 and 0, and another is +2. So these are the three sets. So now actually, but errors may be like your there will be the two, either if is you are the receiving the -2, since here s is equal to the your s plus n. So n will, because of the n, now you are going to face the error. So exactly for n greater than, if I'm considering, then there will be the certain error. And in this side also, if you are considering like lesser than the -1, actually these are the boundaries, means your s is equal to 0 and here is -1, here is your +1. So we are going to find whether probability of n is greater than +1. So these are the chances. Definitely there is chances that we'll get the s is equal to 2, but additionally if the random values are falling in this range, that will be considered as a the noise. So how much will it be? So we will find out the total probability error, finding the s is equal to 2, 0 and -2, and then we'll add, and then we'll get the total probability. Okay, so let's find the probability of finding the s is equal to 2, -2, 0 and 2. So in order to solve it, now let's see. So first is the source transmit the symbol. What are the symbols? Do we have -2, 0 and 2? There are three symbols, right? And with equal probability, always 1 by 3 for each. And at the receiver end, your y is your receiver end. However, y will not be simply equal to s. Why? Because of the n is your error. 0 mean Gaussian noise, right? So because of this noise, so ML decoder, since the symbols are probable, so the ML decoders is equivalent to the nearest neighboring decoder. Okay. So now decision boundary, your decision boundaries are located exactly halfway between the symbols. So between -2 and 0 there will be -1, and 0 to 2 there is +1, as already we have seen in the previous slide, right? So in order to solve your question, now you can go to the previous slide, that is the very important one. Now we are going to calculate the final PE, total error. So how will calculate? So there are the three chances. P will your s will be -2, s will be 0, and s will be the 2. So apart from that, there is a conditional probability, that is P of S is equal to -2, and then P of E by S may not be, that is -2 either. And then similarly P of S is equal to 0, and the conditional probability of E by S is equal to 0. And similarly for P is S is equal to 2 and E by S is equal to 2. So now we will, since P of S is equal to -2 and S is equal to 0 and S is equal to 2, all are how much? 1 by 3 only, right? Because there are three chances only. Chances is, so we are going to find P of E by S is equal to -2 and P E by F is equal to 0 and P of E by S is equal to 2. These three things we are going to find. Then we will put the values and get the total probability of error, that is PE, right? So case 1, let's find first one, that is P of E by S is equal to -2. So here y will be greater than -1. Y is, it should be, you can just check the previous slide. And then y is equal to, so S is equal to -2 plus n. Why? Because S is equal to S plus n, right? It has already been given in question. So S is equal to how much? For this case, E by S is equal to -2, S is equal to -2. So -2 plus n, and it means that n will be greater than 1. So P by S is equal to -2 is n greater than 1. Similarly, for S is equal to 2, you can get n should be less than equal to less than 1, and if it is n less than 1, since this is a symmetry, so again it will be P by E by S is equal to 2. P probability is greater than n greater than 1. But in the case of S is equal to 0, if you are going to the previous slide, you can check there are two lobes in the left side, right side. So both will be added. So P of n less than 1 and P of n greater than 1, and both are equal due to symmetry. So it will be twice of P of n greater than 1. Now we got the values of P E by S -2, then E by S plus 2 and E by S 0. So we will get put all these values in this expression. So P S -2 is how much? 1 by 3. P E by S equal to -2, how much? P of n greater than 1. Then P of S is equal to 0, how much? That is equal to 1 by 3. And then P of E by S equal to 0, how much? This is twice of P and greater than 1. Similarly, we'll put all these values and add, and you will get the 4 by 3 P of n greater than 1. And now in the question itself, it has given, since P of E is equal to how much? Alpha P n of greater than 1. So finally, we'll get the value of alpha is equal to 4 by 3. So as per answer key provided, your option D is correct. Thank you for joining the session. If you have any doubts, please drop your comments.